Okay, folks, we'll pick up today with a couple last questions, off of 5.3, and then I want to get back in and finish up 5.4. We're going to look at, we looked at the doubles yesterday, correct? We did doubles, so we're going to look at power reducings and half angle identities. We're going to get to the power reducings before we get to the half angle identities. But a couple last questions off of 5.3. 30. Just proving the identity in 30. Okay, so again, bless you. We're going to start with one side of the equation, and using identities and substitutions, we're going to try and make it look like the other side. So as I look at the right-hand side, negative sine theta, is there absolutely anything I could do over there? Absolutely nothing. Okay, so that kind of tells me that I need to use the right-hand side, right? So as we look at the right-hand side, what do we have over there? Cosine of what? Yeah, the sum of two angles, right? So what is our identity for the cosine of the sum of two angles? The two cosines are together minus the two sines are together. So go ahead, Will, what's this going to be? Cosine theta. Cosine pi over 2 minus sine theta. Sine pi over 2. Good? Okay, now we don't know what sine or cosine of theta are equal to, but we do know what cosine and sine of pi over 2 are equal to. What is the cosine of pi over 2? Think in degree here, measure here. What's pi over 2? 90. And what's the cosine of 90? 0. Cosine of pi over 2 is 0. Minus sine theta times, what is the sine of pi over 2? Sine of 90 is 1. 0 times anything is 0. 1 times anything is itself. Okay, yep, so you would have gotten cosine theta? Yep. So now 0 minus sine theta, we've got negative sine theta. We have proven our identity. We've shown that the left-hand side is exactly the same as the right-hand side. Okay with 30? Austin, you had one? 54? Prove the identity in 54. Okay, so again, we've got to show that one side looks exactly the same as the other. As I look at the left-hand side, I see I've got a 5u and a 3u. Well, we know about double angles, but do we know about fifth and third angles or anything like that yet? No. So I'm going to kind of look at the right-hand side, because as I look at the right-hand side, it doesn't have the form that I wanted, I guess. Because they're both minuses, aren't they? And we want one to be a plus and the other to be a minus, don't we? $54. Yeah, they're both minus. Let me. What page is it? 468, right? Tangent squared 4u minus tangent squared u over 1 minus tangent squared 4u, tangent squared 4u. If one of these were a plus, it would be the tangent of the sum or difference? All right, let's look at this. So over here in my goal, I've got 4 and 1, right? So over here, I've got 4 and 1, but over here, I've got 5 and 3, right? Well, how can we get 5 using 4 and 1? 4 plus 1. How can we get 3 using 4 and 1? 4 minus 1, right? So let's say that the tangent of 5u is the tangent of 4u plus u, right? Whereas the tangent of 3u would be the tangent of 4u minus a u, right? And now do we have identities for tangent of sum and tangent of difference? Yes. What is the tangent of 4u plus u going to become? Tangent of 4u, tangent of u over 1 minus tangent 4u times tangent u, right? Okay, Austin, do the same thing for me, but now instead of plus, we've got minus. So what's the only thing that's going to change here? Up top, we're going to have a minus, and in the bottom, we're going to have a plus. So tangent 4u minus tangent u over 1 plus tangent 4u tangent u. And it's indicating that we need to do what here? It's indicating we've got to multiply these together, right? How do we multiply fractions? Straight across, right? So I've got to multiply this top to this top. How are we going to do that? We've got to FOIL it out, right? What's tangent 4u times tangent 4u? Tangent squared 4u, right? Anything times itself is just squaring it. Tangent squared 4u. Well, what is going to happen with the inner and outer parts of these FOIL? Why? They're conjugates, right? So what's the last then? A positive times a negative is a negative. And what's tangent u times tangent u? Tangent squared u. We're starting to look like our goal, aren't we? Yeah, we're starting to get there. Okay, tangent squared 4u minus tangent squared u. All right, how am I going to multiply this bottom to this bottom? Same thing, right? And again, are they conjugates? Absolutely they are. So what's 1 times 1? 1. What's going to happen with the inner and the outer part? Cancel each other out. And the last is a positive times a negative, which is a minus. And what's tangent 4u tangent u? Times tangent 4u tangent u. Tangent squared 4u times tangent squared u. Have we proven the identity now? Yes. Okay, the connection we needed to see on this one here is that over here I've got 4 and 1. Over here I've got 5 and 3. So plus and minus. Okay, I can get 5 by taking the 4u and adding it to u, and I can get the 3 by taking 4u and subtracting off the u, and now we can expand those out into the 2 different ones. All right, 54? Okay, one more. Jared, you had one? Oh, that one. Same one. Was there somebody else that had a different one, Cheyenne? 45. Express the function as a sinusoid. Never understood why they put this one in this lesson, because it should have been in the last section. Sorry, not last section, but last unit. It was just a sinusoid. Why? They have the same frequencies. They both have a frequency of 3, which means they're going to have the same what? It means they're going to have the same period. Okay, so how are we going to figure out how to write this in the form that they want? Well, we've got to graph this out. And when we graph this out, we are going to need to find a maximum value. And we're going to need to find a minimum value. And what will we use that max and min to determine? Our amplitude. How will we determine the amplitude? We will take the max minus the min and divide it by 2. We will also use that to determine the what? The midline, which is what? Max plus the min divided by 2. We already know that we're going to have a B value of what? 3. We're going to have a B value of 3, and we might need to determine if there is going to be a phase shift. What is the form that they want out of this? Boom. Yep, we're going to have to determine because they wanted a sign. They want y equals A. Y equals a sine of AB, x plus or minus a c. So we're going to have to graph that to determine. Now, where do sine curves start at? They have midline. They start at the origin of the midline, so we're going to have to see however many units we shifted over to the left or the right to determine that. Okay, so let's go ahead and look at this then. So we've got cosine 3x plus 2 sine 3x I'm going to make sure we're in what mode? I'll be in radian mode. I'm just going to go from negative 2 pi to positive 2 pi. Why 2 pi's? That's the standard period for these. What is our period? If a frequency is 3, what's the period? 2 pi over 3, so we don't need quite that much, but it doesn't make a difference. Pi divided by 2, we'll cut it into the quadrants. What's the amplitude of this, just this part? 1. What's the amplitude of this one over here? So if they happened to line up at the same spot where their max and mins would match, what's 2 plus 1? What's negative 1 minus 2? Negative 3. So at most, my amplitude would be what? 3 and negative 3. So that should cover what we want because they're definitely not going to hit at the same spots. Okay, so here's our graph. And again, we need to find this max and the min, and I'm going to use the first max and min that are to the right. So I need you guys to find that maximum right there. Okay, you guys are going to find that point for me. I'm going to find this one. So you guys are going to find the max. I'm going to find the min. What'd you get? Yep, and where did it occur at? X equals 0.369. ... so on and so forth. Okay. And now, ultimately, no, we don't need to know the x values because we already know that this is going to have a period of 2 pi over 3 and our frequency is going to be 3. So, ultimately, in this case, no, we don't need the x values. Normally, yes, we would. Okay? So, what happens when I take this value and subtract off its negative? No, it's negative. We're subtracting a negative. So, we're just doubling this value, right? Well, if I double this value and then divide it by 2, I'm right back to what? So my amplitude, 2.236, ... My midline, what's going to happen when I take a number and add it to its negative? Now we're getting 0. Our midline is what? 0. We know our frequency to be 3. Okay? So I know right now I've got y equals 2.236 sine. We know our b value is 3. We just need to figure out how many units we needed to shift this to get to where we want to be. Okay? So, a sine curve starts where again? At its midline. Well, where is the first place that's closest to the y-axis that it would start at its midline and increase like a sine curve? No, it's not the origin. It's close to the origin, but it's not the origin. We need to find this 0 right here. We need to find this 0. So is it going to be an x plus or an x minus? It's going to be a plus. Why? Because it's slightly to the left. It's slightly to the left. So let's find that 0. Second trace, 0. Option number 2. Left puts me, right over there will work for the left. Right will put me up there. That's fine, I guess. So we are, how many units? 0.155? Okay, so plus 0.155. Get us there. What should we do now? Yeah, we should type this into y2 and make sure what? That it follows the exact same path. We've got to make sure it follows the exact same path. Okay. We're going to get moving back on into 5.4. Folks, if we still have questions, you need to get in and see me on those questions. We cannot continue to take full periods to go over homeworks, especially when these homeworks are mainly review of identities that we did last year. So if we've got more questions, we've got to come in and get them taken care of outside. We did the doubles, correct. And how did we derive the double angles? What identities did we use to derive the double angles? The sums, right? But instead of having two different angles, a u plus and a v, we had a u plus u. Okay, so a u plus u. So any questions on our double angle identities here, folks? And again, what was nice about cosine? There's 3 of them. One strictly in terms of cosine, one strictly in terms of sine, and one that has both. Okay, so cosine was nice for us. We could run through those and run through. And here's the proof of the double angle identity, which is exactly what we did yesterday. Any questions on the proof of the double angle identity? Okay, so how do we get 2x? Well, we take an x and add it to another x. Well, now I know an identity for a cosine with adding. It's cosine x minus sine x sine x. Well, cosine times cosine is cosine squared. Sine times sine is sine squared. We subtract those out. Okay. How did we get those other 2 then? Well, we replaced cosine squared with what? 1 minus sine squared. Or we replaced sine squared with 1 minus cosine squared. Those were what identities? Pythagorean identities. We substitute those in. Okay. Power reducing identities. Okay. These ones are completely new to us, these power reducing identities. And what they allow me to do is they take, and it doesn't necessarily need to be a square, it can be a 4th power that we can then turn into a square. But if we have these sine squareds, cosine squareds, and tangent squares, we can reduce those down to a 1 minus cosine 2u over 2, 1 plus cosine 2u over 2, and what we're going to do here is we're going to prove one of these. If we can prove one of them, it lays the format for being able to prove all of them. Okay, so let's take a look at the sine one, and we will prove the sine one. And how are we going to prove this sine one? Well, now that I know cosine 2u, we're going to use that. Okay. So folks, as I look at this one, sine squared u, is there much that I can do with sine squared u? There's a couple things I could do with sine squared u. I know that sine squared u is equal to what? 1 minus cosine squared u. 1 minus cosine squared u, that's the difference of 2 perfect squares. I could factor that down to 1 plus cosine u times 1 minus cosine u. But is there anything else I could really do with that? There's nowhere else I could go with that. Okay? But there is something I could do there if I get stuck on the other side. But let's look at the other side. What's blaring out at us at the other side from what we did yesterday? The double angle identity, right? Okay, so let's go ahead and make that substitution for the double angle identity. I've got 1 minus. Now this one thing is going to become multiple things. I need to have a what? Parentheses, because we're going to have to distribute that negative all the way through. Okay, now look at my end game here, folks. I ultimately want to end up with a what? Sine. So which identity should I use for the cosine of the double angle? The sine one. What is cosine 2u equal to? 1 minus 2 sine squared u's divided by 2. What do I have to do now? I've got to distribute the negative up on top. What's that going to give me? Minus 1 plus 2 sine squared u's, right? All over still. Okay, what do we get from there then? 1 minus 1 is nothing. 2 sine squared u over and what happens there? 2's cancel out, leaving me with sine squared u. Have I proven this identity now? Absolutely, I've proven this identity. Now, how is this helpful for me? Well, it's helpful to get rid of the power. Okay, if I don't want to have a power, then I can reduce it out. Okay? Sine squared is equal to 1 minus cosine 2u over 2. And these power reducers are really going to help us with our half angle identities. If you'll remember the half angle identities, we did derive a couple of them last year, but the half angle ones were the ones that I said we're not at the level yet where we can do these. You've just got to take my word for it, that the sine of 1/2 of a is equal to the positive or negative square root of 1 minus cosine a divided by 2. Cosine was 1 plus cosine divided by 2. I just said you had to take my word for it this year. We're not at the level where we can do them yet. Why were we not at the level? We didn't have these power reducers. Okay? Well, these power reducers are going to help us to be able to find the angle that we want for half angles. They're going to make it much easier for us. Okay? So the power reducer for sine, if we have sine squared is equal to 1 minus cosine 2u over 2. Cosine squared is very similar. Cosine squared is equal to 1 plus cosine 2u over 2. And tangent is sine over cosine. So if I take this sine and divide it by this cosine, we don't divide by fractions, we multiply by what? So what's going to happen to the 2's? They're going to cancel out, and I'm going to have the 1 minus cosine 2u over 1 plus cosine 2u. Okay, so those are our power reducers. How are these power reducers then going to help me to find a half angle identity? Okay, well, let me do this. Instead of having u here, let's change that angle to be half of u. Okay, so sine squared, and I'm going to kind of outline this. Let's let u equal 1/2 of x. So what I'm going to do is wherever I have a u, I'm going to replace it with what? So sine squared of 1/2 x, and is everybody all right with me writing x over 2? Okay. Sine squared of x over 2 would have to be equal to 1 minus cosine of 2 times x over 2 divided by 2. Is everybody comfortable with what I just done there? So what I'm trying to set up here for you is the half angle identities. Okay, what is the sine of 1/2 x? What is the cosine of 1/2 x? So on and so forth. So by this substitution here, I'm setting up the half angle identities for you. Okay. Well, I don't want to know what sine squared of 1/2 x is equal to. I just want to know what the sine of 1/2 x is equal to. How do I undo squares? By square rooting. We're really raising to the reciprocal power. What's the reciprocal of 2? 1/2, and what's a 1/2 power? The square root. Okay, so if I take the square root of both sides, now when we bring in the square root, what has to come with it? The plus minuses, right? So over here, the square root is going to cancel the square, and I'm going to be left with the sine of x over 2, the sine of a half angle. Well, that's going to be equal to the positive or negative, and we're going to have to take that into consideration if it's going to be positive or negative, square root of 1 minus, now what happens here? The 2 times x over 2, what does that give me? That just gives me x, right? 1 minus cosine x divided by 2. There we go. There's our half angle identities. But again, last year, did we have these power reducers? No. We didn't have this power reducer that said that sine squared was equal to 1 minus cosine 2u over 2. Algebra 2 trig doesn't get to the level of the power reducers, which means at Algebra 2, then, we really can't go through the proof of the half angle identity. Well, now that we've got these power reducers, we can go through the proof of the half angle identities. And it's going to be the exact same thing for cosine as well. But instead of having 2u here, it's going to be 1 plus cosine x divided by 2, 1 minus cosine x plus, over 1 plus cosine of x. So that's where we get our half angle identities from, as well as these power reducers. Okay. So here's our power reducers. Here's our half angles. Okay. And again, how did we prove these half angles? Right from the power reducers. How many identities do we have now, folks? You hopefully have a separate sheet of paper, and on that separate sheet of paper, you've started off with reciprocal identities, quotient identities, Pythagorean identities, cofunction identities, even odd identities, 5 sets from section 5.1. 5.2 then went into sum and difference identities. You should have the sine, cosine, and tangent of the pluses. 5.4 then started with doubles. We then just went into, before that, power reducers. You should now have a separate sheet of paper that has how many sets of identities on it? 9 sets of identities. You should have 9 sets of identities on that one single sheet that's used for reference. Folks, if you don't have this yet, then you're putting yourself at a severe disadvantage for doing your homework, because you have to look back through all of your notes and try to find which one I'm looking for, which section is it in. I should be looking right to a separate sheet of paper that is right by my side that has all 9 of these sets of identities. Now, we're probably close to having like 30 individual identities. Again, Pythagoreans, there's how many Pythagoreans? There's 9. There's 6 reciprocals. There's 2 quotients. Even and odd, there's really 6 even and odd. There's really 6 cofunctions. We should have 9 sets of identities right next to us as we're doing our homework, and we should be studying off them as well. Okay. Are you going to have that sheet with you when you take a quiz? Absolutely not. Okay. We need to start understanding and memorizing these identities. Okay. So, we're going to get to an example here in just a second of using the half angle identities, and again, the plus and minus is important, but what do you notice for tangent that we didn't talk about last year? Did we have these 2 last year? No. We did not have these 2 last year, which makes it kind of nice this year. Tangent, I don't necessarily have to determine the plus or the minus if I use these. What's the drawback, though. What's nice about this one? It's not as nice about these two. This one's strictly in terms of cosine, where these ones are both. Now, what's nice about these ones, though, is I don't have to determine the plus or the minus. And, folks, if you know one trig ratio, you should be able to figure out all the other ones, right? You should be able to figure out the other ones. Okay, so if I know the cosine up here, I'm going to go ahead and use what the cosine is and figure out what the sine is. And then I don't even need to worry about figuring out if it's the plus or the minus. I can just run it through this. 1 minus cosine u over sine u, or sine u over 1 plus cosine u. Either way. All right, let's take a look at an example of this. That's not an example of that one. Where's our half angles? I want more of an application of it, not really proving the identity. Let's.
May I have your attention, please? The afternoon announcement. The library will be closed during activity period today. There will be a prom committee meeting during activity period today in Ms. Pawlowski's room. Attention all National Honor Society members. The county banquet is tonight. Please meet in the gym foyer no later than 5:25. Seniors who plan on attending the senior tea on Friday, May 15th from 3 to 4 p.m. at the miners' cabin may have an 11 o'clock dismissal that Friday if they return the signed permission slip to Mr. Butler by next Monday, May 11th. Anyone who leaves early must attend the senior tea. Questions, please see Ms. Pawlowski or Mr. Butler. Any senior planning on attending the junior-senior banquet on Friday night, May 15th, in the elementary cafeteria from 6 to 9 p.m. should sign up outside Mr. Butler's room. Swimming, basketball, kickball, and other games are available. Hot dogs, hamburgers, and other picnic food will be served. Seniors who work the Maple Festival go free. All others going, there will be a $10 charge. The modified softball and modified baseball teams change at the end of ninth period today and come to the track level of the gym for their individual and team picture. Anyone doing an individual portrait for golf or varsity softball team should change after signing out of their homerooms during activity period. Team pictures will be on a first-come, first-served basis. All members of the team must be present and in uniform. Varsity baseball individual pictures may be done after golf and varsity softball. The team picture will be taken after West Valley players arrive at 3:10. All track teams should change into uniform at 3:15 and report to the gym in uniform, not the track level. Team pictures will be taken after the Elkville students arrive at 3:40. Anyone needing an individual portrait may come to the track level after golf, baseball, and softball have finished. There is recycling today during activity period. Anything that needs recycling should be placed in the hallway. National Junior Honor Society students, please sign out of homeroom before coming to recycle. Following students, please report to the office. Kaylin Larson, Jake Pollock, Kelsey Brown, Carolyn Wright, Kaylee Ammerheim. Thanks for your attention.
As soon as I talk, they're going to beat that. All right, we saw an example very similar to this when we were doing the sum and difference ones. We wanted to find like the sine of a 75-degree angle. Well, 75 is not one of our special values. So we found out that we could get 75 by doing what? Adding 45 and 30. Well, very similar here. 195 we can get by using a half angle. 195 is half of what? Double that for me. What's 195 times 2? What is it? 390. No, shoot. We're going to pick this up tomorrow. Again, folks, this is 5-4. So the 5-3 is due. If you still got questions on it, get in and get them taken care of, okay?